Television programs always have pathologists going to a murder scene. And the very first question any pathologist would ask, a real one, is, when did he die? Because they don't want to be spending a lot of time investigating a murder that happened 1,000 years ago. This is the science. There are two types of carbon in your body. Carbon-12 is stable and lasts forever. C12, 6. 6 protons, 12 protons plus neutrons. Carbon-14 is unstable. C14, 6 protons. Always 6 protons in a carbon. Unstable atoms change into stable atoms by emitting a proton or a gamma wave. Gamma ray is a better word. Okay. I think that needs a copper and that needs a full stop. So there's two changes there. One atom in a trillion carbon atoms in your body is carbon-14. Well, as long as you're alive it is. And I'm assuming, seeing as you're watching this, that you are. If you die, you stop eating. Yeah, you do. So no more carbon-14 is entering your body. And so the amount of carbon-14 decreases. Because it's unstable, it splits apart. After 5,730 years, half of your carbon-14 has changed to nitrogen-14. This is called decay. Oh yeah, the rest of you is decaying as well. Well, I think I can do without the brackets there. Do you reckon the brackets should go? No, I do. C14 with 6 protons. 5,730 years. Half of it. Oh, the word half. Becomes nitrogen-14 plus a beta. After 3,730 years, this only works for carbon-14, the 5,730 years. There is only 1/4 left. After another, yes. Beta particles, beta, are fast-moving electrons. Absolutely. You see that? Beta causes damage because it is going so fast. Up to 30 million meters per second. Oh yeah, not for a long distance, but yeah, for short distances. Or 10% the speed of light. The amount of carbon-14 halves every 5,730 years. So 5,730 years is called carbon-14's half-life. Yeah, half of it's gone. A piece of dead body is put into a mass spectrometer to find out how much carbon-14 is left. Spectrometer. The mass spectrometer, T, tells you how many carbon-14s are in a trillion carbon-12 atoms. If there is 1 carbon-14 in a trillion carbon-12, the body is less than 1,000 years old. If there is 1 carbon-14 in 2 trillion carbon-12s, the body died approximately 5,730 years ago. If there is 1 carbon-14 in 4 trillion carbon-12s, the body died approximately 11,000, hold on, I've got to double this, 11,430 years ago. Yeah, the amount of carbon-14 halves. The ratio halves every 5,730 years. All isotopes have a half-life. Carbon-14 is a good one for using for dead bodies. During the decay, a neutron becomes a proton. And a beta particle. Hold on, is the word proton up there? Got to check that. Neutron becomes a proton plus a beta particle. An unstable isotope of carbon is carbon-14. Isotope. The unstable isotope of carbon has 6 protons and 8 neutrons, giving carbon 14 an atomic weight of 6 plus 8, 14. That's where the 14 comes from. The half-life of carbon 14 is 5,730 years. Carbon 12 has 6 protons and 6 neutrons. Usually protons and neutrons are about the same for most atoms, giving carbon 12 an atomic weight of 6 plus 6 is 12. If the mass spectrometer detects 1 carbon 14 in every 8 trillion carbon 12s, okay, and that's like 8 half-lives. The body died approximately oh heck. Right, put that in a computer, calculator. Put that down below. I haven't got my calculator with me. Go!